Okay, so for Math 113, Lesson 5.2 is right triangle trigonometry. So I'm going to draw for you a right triangle. That means there is one right angle and two acute angles. All right, so for the time being, we will call this triangle ABC, and we will let the side opposite angle A be little side A, the side opposite side angle B be little side B, and the side opposite angle C be little side C. And we're going to put theta, our angle that we're talking about, right here in angle A. All right, and so angle A, we've labeled it with theta, that's the angle that we're working with, is definitely an acute angle. All right. So before we get too far, I do want to review with you Pythagorean theorem. You might remember this from high school. You might have zero recollection about it whatsoever. But the Pythagorean theorem works only in right triangles, and it says that when we add the two legs squared together, it is equal to the hypotenuse squared. So that means we got to know which sides are the legs and which ones are the hypotenuse. Well, the hypotenuse is the easy one. It is the one that is always across from the right angle. So A and B are both the legs. So the Pythagorean theorem says A squared plus B squared equals C squared. So let's just practice a simple one of those. If I know that A is 3 and C is 5, then we can find B by using our Pythagorean theorem if I know for sure that this is a right triangle. So I would have 3 squared plus, we don't know B, so we're trying to find that one, and then 5 squared. We'll substitute 3 for A and 5 for C. So I get 9 plus B squared is 25. So I'm going to move that 9 to the other side by subtracting, and I would get B squared is equal to 16. So when I take the square root of both sides, now algebraically, I'm going to get B is plus or minus 4. But since we are talking about B is the length of a side in a triangle, then B is only going to be the positive value. So B is going to be 4. All right, so there's just a little review of Pythagorean theorem. That's just old news. All right, so something else that we need to talk about. We labeled this hypotenuse. The other two sides, for the sake of what we're doing today for trigonometry, have other names. We have the side that is called opposite would be the side opposite whichever angle is labeled as theta. We will call it opposite. So that's what it means. It's opposite theta. And then the other side is called adjacent. It would be adjacent to theta, which means it actually is a side that is connected to theta. So we need to know their names, opposite, adjacent, and hypotenuse, so that we can work with that when we're doing our trigonometry. All right, so there are 6 trig functions that we need to look at today. All right, the first 3 you may be familiar with: sine, cosine, and tangent. Now these are the actual words. The symbols that we use to talk about sine would be S-I-N. We do not read that sin, we read it sine. Okay, C-O-S would be cosine, and T-A-N would be tangent. We don't read them sin, cos, and tan. We read them sine, cosine, and tangent. And we're always taking the sine, the cosine, and the tangent of some angle. In this case, angle theta. So we need to know, how would I find the measure of the sine of theta? Okay, that is always in relation to the sides that we've just talked about. So we would take the opposite side. Okay, now we just labeled that on our diagram, and we put it over the hypotenuse. So in this diagram that we have, our opposite side was that little a, our hypotenuse was that little c. The cosine is adjacent over the hypotenuse. And so if we look at our diagram, our adjacent side is B and our hypotenuse is C. And then tangent is the opposite side over the adjacent side. I didn't spell that correctly. So our opposite side is A and our adjacent side is B. So that would be A over B. Now, I told you there were 6 trig functions. Okay. So the other 3 trig functions have names. They are the cosecant, the secant, and the cotangent. So the symbols that represent that would be cosecant, we use CSC. So the cosecant of theta. The secant of theta would be SEC, and then the cotangent of theta. All right, so there are those symbols. Now, the good thing about these 3, I'm going to space them out just a little bit better for me to work with. All right, so the good thing here is that they are related to the 3 that we've already drawn, the 3 that we've already talked about, sine, cosine, and tangent. The cosecant is the reciprocal of sine, the hypotenuse over the opposite, which is C over A. Notice, these 2 are reciprocals. The secant is the reciprocal of the cosine. So it would be C over B. And then the cotangent is the reciprocal of the tangent. So it would be adjacent over the opposite. So B over A. So if I can do the first 3, then the next 3 are reciprocals, which means you just flip it over. And that makes things very convenient for us. Another reminder about the first 3. You may have seen this somewhere else, Sakatoa. The only problem with Sakatoa is people forget how to spell it. So when I use Sakatoa, I use the phrase, some old hag came around here teaching old algebra. And that way you know how to spell it because it starts with those letters. Some old hag came around here teaching old algebra. And so the reason that's helpful is I know that the sine of theta is, and then I can use these little letters right here, okay, because that would be opposite over hypotenuse. And so that's how you use this little tool. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. So that is up to you if that's just one little trick that you can use to help you remember the first 3. Once you know the first 3, the others are reciprocals. Now, when you're doing the reciprocals, the reciprocal of sine is cosecant. Okay, the cos don't go together. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. All right, moving along. So that's going to be information that you need to have handy if it is hard for you to memorize. So I'm going to draw you another triangle, and we're going to do an example here. Okay, so here's our right angle. There's A. Now, capital A, capital B, and capital C are different from little a and little b and little c. Okay, they are not the same thing. Capital A, B, and C represent angles. Little a, b, and c represent sides. All right, so for our first example, we are going to find the value of each of the 6 trig functions of theta. All right, so those 6 trig functions would be the sine of theta, the cosine of theta. Okay, that's the first 2. Then we have the tangent of theta, Sakatoa, there we go. Now, the reciprocal of sine is cosecant, so I like to write it beside it. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. All right, so we have to find each of these. Awesome. Now, each of those is a relationship with the sides. I have to know the sides of the triangle. Well, I know two of them. I must find the third one. So first, I need to find C, little c. And I'm going to use Pythagorean theorem to do it. A squared plus b squared equals c squared. Now, I don't know what you're used to as far as math is concerned, but I am a stickler for you showing your work. Yes, even in an online class. So please make sure that you show your work when you're doing things for me. I am going to ask to see it. All right, so I got C was 5. Awesome. So I'm going to write it a different color because I didn't originally know it. All right, so I found that C is 5. All right, so I'm going to use that to help me answer all of my trig functions. All right, so the sine is the side opposite A over the side that is the hypotenuse. So when I look at theta, opposite theta is that little a, which is 3. The hypotenuse in this particular triangle is 5. All right, so maybe it's helpful for you to label them. Okay, I know this is the hypotenuse because it's across from the right angle. I know this is opposite because it's across from theta. And then I know that this one would be adjacent. Now maybe that helps you to be able to answer all of these. All right, the cosine is adjacent over the hypotenuse. And then our tangent is opposite over adjacent. Boom. Now for cosecant, secant, and cotangent, now since I have them lined up with their reciprocals, I just flip it over. So cosecant of theta is 5/3 because it is the reciprocal of sine. Secant is 5/4 because it is the reciprocal of cosine. And cotangent is 4/3 because it is the reciprocal of tangent. And we are done with that problem. All right. So let's move on. Sometimes, unfortunately, our answers don't look as nicely as those fractions did. So let's do one that our answers don't look quite so nicely. All right, so find the value of each of the 6 trig functions of theta. Now here's where you got to be careful. The directions are going to say express each value in simplified form. And so that's going to be super important. My math lab is going to throw your answers out and tell you they're wrong if they are not simplified. All right, so let me draw our little triangle for us. Looks a little different this time. Okay, here's A, B, and C. Those are angles. I'm going to put theta right here. So my A value is 1. My C value is 5. This time, I don't know what B is. Okay? And so we are asked to find the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Before I can do any of that, I must first find B. Okay, so we do that with the Pythagorean theorem. All right, so A squared plus B squared is C squared. So I move that 1 to the other side. I get B squared is 24. Okay, so when I square root both sides, I have to do the square root of 24. Let's see if I can move this little thing. No, I cannot. All right, so the square root of 24 is 2 on the square root of 6. Awesome. Okay, so I'm going to write that in a different color because I didn't originally know that. All right, 2 on the square root of 6. Now I'm ready to find sine, cosine, tangent, cosecant, secant, and cotangent. All right. Again, it might be helpful if you label your sides with opposite, adjacent, and hypotenuse. The hypotenuse is across from the right angle. Opposite is across from theta, so this would be considered opposite. And then adjacent actually is connected to theta, so 2 on the square root of 6 would be our adjacent. All right, now we're ready. Sine is opposite, so 1 over hypotenuse, 5. Okay, awesome. Cosine, adjacent over hypotenuse. Great. Tangent of theta is opposite over adjacent. Uh-oh. All right, slight problem here. Okay, now this is where simplified form comes into play. You cannot leave a square root in the denominator. Okay? So I'm not sure if you remember how to do that, how to get rid of the square root in the denominator, but it's called rationalize. So to rationalize this denominator, I multiply the numerator and denominator by the square root of 6. That gives me square root of 6 in the numerator, and in the denominator, 2 on the square root of 36. Okay, well 36, the square root of 36 is 6. So I really have the square root of 6 over 12. So my tangent is the square root of 6 over 12. Awesome. All right, I'm going to slide it over so I can write the other ones beside them. Okay, I like to write the reciprocals beside each other. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So the cosecant, we flip over the sine, would be 5 over 1, which is just 5. The cosine, we flip over, yes, we flip over the cosine to get the secant, and we get 5 over 2 on the square root of 6. Uh-oh. Can't do that, remember? Can't have that. Can't leave that square root in the denominator. So, again, I need to rationalize. So multiply by the square root of 6. And I end up with 5 on the square root of 6 over 2 times 6 would be 12. All right, so 5 on the square root of 6 over 12. And then my cotangent, I flip over the tangent. Now, I have some choices here. I can flip over this one, but then I'm going to have a square root in the denominator. Or I could go all the way back. Let me use a different color so I can show you. I could go all the way back to right here. Okay, because that's the first tangent that I wrote down. If I flip that over, oh, that'd be great. It'd be 2 on the square root of 6 over 1, which I don't have to rationalize. So my answers are all of those. Sine, cosine, tangent, cosecant, secant, cotangent. All right. Lots of information in this lesson. Okay. The next thing, hopefully you guys know how to go to your textbook in My Math Lab. If you do not know how to get to your textbook, that would be a great thing for you to ask me in a Teams meeting or email for me to show you how to get to your textbook in your My Math Lab. So there is a table on page 564 in your textbook. Great table. I'm not a big table person, but if you like to memorize things in table form, this would be a great table, okay? Because you're going to need to know the information in this table. Now I'm going to give you some ways to know it without knowing the table, but some people just like tables. So there's an option for you to go to that page to know the table. All right, our special angles. We have a 45, 45, 90 triangle, and we have a 30, 60, 90 triangle. And so those are our special angles that we're worried about. We're worried about 45 degrees, 30 degrees, and 60 degrees. We're not going to look at 0 and 90 right now. Okay, now another thing I want to point out, we've already talked about radians. So 45 degrees is pi over 4, 30 degrees is pi over 6, and 60 degrees is pi over 3. So we can't lose sight of that information. Okay, so let's draw these two triangles, all right? All right, so in a 45, 45, 90 triangles, our legs are both 1, and our hypotenuse is the square root of 2. In our 30, 60, 90 triangle, looks slightly different. Okay, our legs are 1 and the square root of 3, and our hypotenuse is 2 on this one. Okay, so we're going to look at sine, cosine, and tangent of these special angles, 45 degrees, 30 degrees, and 60 degrees, using these two triangles that we have drawn. Now, you can either memorize the triangles, or you can memorize the cute little table that I told you to go to on page 564, or I'm going to show you another thing called a hand trick, which is my absolute favorite, but you have options to do it however you want. Okay, so if I've got the triangle though, it's really simple. The problem with the triangle is I forget how to draw the triangle sometimes. So if you will forget sometimes how to not draw the triangle, but label 1, 1 and square root of 2, or 1, 2 and square root of 3. So that gets a little crazy. All right, so if I just said, hey, let's look at this triangle and find the sine of 45. Well, that would be opposite, which would be 1, over hypotenuse, square root of 2. I must rationalize. Okay, can't leave a square root in the denominator. So that would be the square root of 2 over the square root of 4, which is 2. All right, let's do the cosine of 45. Okay, the cosine of 45 degrees is the adjacent over the hypotenuse. Rationalize. You get exactly the same thing as you got for the sine. The tangent of 45 is opposite over adjacent. So it's just 1. All right, so the table on page 564 gives you these values. You can either memorize those values, or the triangle that helps you get there, or I'm going to show you a little hand trick in just a little bit. All right, let's go on to 60 degrees and 30 degrees. Let's start with 30. All right, so if I've got my triangle sitting up here, opposite of 30 is 1, the hypotenuse is 2. The cosine of 30 degrees would be adjacent of 30, which is the square root of 3, over the hypotenuse 2. And the tangent of 30 degrees would be opposite, which is 1, over adjacent, square root of 3. You cannot leave a square root in the denominator, so we must rationalize. Square root of 3 times square root of 3 is square root of 9, which is 3. Awesome. All right. Now let's do sine, cosine, and tangent of 60. Okay, we still got our triangle to look at, so this is really doable. Okay, so the opposite of 60 is the square root of 3. The hypotenuse is 2. The cosine of 60 would be adjacent, in this case would be 1, the hypotenuse is 2. And then the tangent of 60 would be opposite, which is square root of 3, over adjacent, which is 1, so the square root of 3. Awesome. Okay, so you need to memorize that table on page 564. These are going to be values that you're going to need to know, and you're going to need to know them from memory. We only have 10 weeks in the summer. Chances are you're not going to be able to memorize these very quickly. I suggest you either draw that table and memorize it and like have it with you every time you do your work, or you memorize this little hand trick that I'm about to show you. Okay, now let me just say, not an artist, okay? So I'm going to draw a hand. Okay, just bear with my little hand that I'm drawing. Okay, lovely little hand. Okay, not an artist, guys. All right, so there's my hand, and here's the way I want you to think about the hand. I want you to think of your pinky as 0 degrees, your ring finger as 30, your middle finger is 45, your pointer finger as 60 degrees, and then your thumb, since it's sticking straight up, would be our 90 degrees. I promise my fingers don't look like that. Okay, and in the palm of our hand, we are going to put the number 2, all right? And in each of the fingers, I want us to put the square root of 1. All right, now bear with me. This little trick is awesome. Okay. So, all right, so that's the way we're going to look at it. All right, now the value of the square root of 1 is actually 1. Okay, so you're like, why didn't you just put 1? Okay, it's a trick, okay? It's one of these silly little things that instructors show you to help you remember stuff. It is a little trick, so if you don't like tricks, you can fast forward through this part. Okay, so when we are finding the sine of some angle, okay, theta, we are going to look at our fingers, and here's what we're going to do. We're going to put down whatever finger that is. So you would bend that particular finger. Or I could think about it like this. I could mark it out. All right, so let's say that I'm talking about the sine of 30. Okay, so I'm going to just mark it out. Now, if I were standing in front of you, I would show you that I'm bending my finger at the knuckle so that it looks shorter than all my other fingers. Okay. So here's what I'm going to look at. For the sine of 30 degrees, I look at what's on the bottom of that pink line that I have drawn. And then I look at what's in my palm. Okay? Hand trick. All right, so if we're doing the sine of 30 degrees, okay, I drew that little pink line where my 30 degrees is. If I look at what's below that pink line, I have that square root of 1. Okay, my pinky. Okay, that square root of 1, which has a value of 1. The number that's in the palm of my hand is 2. Oh, look at there, guys. Look at there. The sine of 30 is a half. Now, you may hate this. You may think it's silly. I love it. I'm going to do another one. Cosine is always what's on the top over the palm. Okay, so let's say I say the cosine of 30 degrees. Okay, because I've got that little pink line drawn. All right, so if I got the 30 degrees would be where I drew that little pink line. All right, so if I were standing in front of you, I put that little finger down, my ring finger down, and then I look at what's on top. Well, the stuff that's on top would be I have 3 fingers. I have 2 fingers and my thumb. They all have a square root of 1, so I call that square root of 3 because I have 3 of them. That's where it gets a little tricky. Okay, so I call that square root of 3, and then in my palm I have 2. Oh, look at there, guys. The square root of 3 over 2 is definitely the cosine of 30. This is such a cute little trick. All right, and then the tangent of theta, right? A tangent would be whatever's on the bottom over the top. Okay, so let's do the tangent of 30 degrees. Okay, got my little pink line at 30 degrees, so the stuff that's on the bottom is 1. The stuff that's on the top is the square root of 3. Oh, you can't leave a square root in the denominator, so now I have to rationalize. And I get the square root of 3 over 3. So the tangent of 30 is the square root of 3 over 3. And one more time, look at there, guys. Tangent of 30 is the square root of 3 over 3. So this works with 45 degrees. It works with 60 degrees. Little tricky if you try to do it with the 0 and the 90, but it definitely works with the 30, 60, and the 45. All right, moving along. Enough tricks. Okay, there are some identities. They are called trig identities. Again, these are things that you're going to need to be able to use. So this would be something I'd write on a note card, have handy beside me as I'm doing my work. Right? So your trig identities. There are some that are called reciprocal. Now we've just talked about reciprocals a little bit. And they're really what we just talked about. Our reciprocal identities, we know that sine and cosecant are reciprocals. So I could write it like this. And then I know cosecant is 1 over the sine. Okay, which is what we were doing. We were flipping it over. Okay, that's what we were doing. The cosine of theta is the reciprocal of the secant. So secant of theta is the reciprocal of cosine. And then tangent of theta is 1 over the cotangent of theta. And cotangent is 1 over the tangent. All right, so these are reciprocal identities that we are going to use, and you need to have them handy. I can't tell you how much you're going to use them. It is going to be a lot. Okay, so these are going to be things you want to have handy. There's two others that I like to have go along with this. They're called quotient identities. And it's another way of writing tangent. We can write it as sine theta over cosine theta, which means that we can also rewrite cotangent as cosine theta over sine theta. Again, you will use these a lot. So it would be great if you have these written down and you have them beside you, ready to use. So I'm going to show you in an example right now how we would use these. Okay, so given that our sine of theta is 2/3 and cosine of theta is the square root of 5 over 3. What I want us to do is find the value of the 4 remaining trig functions. Okay, so we've got sine and cosine up here. So that means we're asked to find the tangent, we're asked to find the cosecant, the secant, and the cotangent. Okay, that would be the 4 that are remaining. All right, so we've got to find all 4 of these. All right, so let's see how we would do that. All right, I know that sine is 2/3. So I have to find the one that is the reciprocal. Okay, remember, sine and cosecant are reciprocals. So cosecant, you just flip over the sine. Done. Just that simple. Okay. Cosine is the reciprocal of secant. So if I take cosine and flip it over, I will have my secant. Now, can't leave a square in the denominator, so we will rationalize. So I get 3 on the square root of 5 over 5, because square root of 5 times square root of 5 is square root of 25, which is 5. Okay. Now, cotangent. Now, remember I wrote for you cotangent was, I could write cosine over sine. That was one of the last ones I wrote for you. Excuse me. So let me write it in words just so we can see it happen. All right, so I know that much. Well, I know that the cosine is the square root of 5 over 3. And I know that the sine is 2/3. A fraction in a fraction. That is not simplified. So I've got the square root of 5 divided by 3. I'm going to just rewrite this so that it looks like a division symbol instead of the division bar. That is an equal sign, guys. All right. So when you divide fractions, you flip over the second fraction. So we multiply by the reciprocal. Awesome, because now 3 goes into itself, and I'm left with the square root of 5 over 2. So the cotangent of theta is the square root of 5 over 2. So the only thing we're missing is the tangent. Okay, well tangent is sine over cosine. So 2/3 divided by square root of 5 over 3. Use our same little process. 2/3 divided by square root of 5 over 3. 2/3 times 3 over the square root of 5. Yay! I get 2 over the square root of 5. Oh, but you can't leave a square root in the denominator. So we rationalize. And I get 2 on the square root of 5 over 5. So that's how we will use those little reciprocals to help us out. All right. Moving along. Okay. The next thing we have is Pythagorean identities. All right. So this is just more of those identities. This is what their name is. All right. So again, this is going to be something that you want to have handy, close by, so that you can refer to it when you're working problems. Right, there's one of them. Another one. 1 plus tangent squared equals secant squared. Notice my squared is on the word, not on theta. All right, so we will use these Pythagorean identities also to do problems. For example, if I am going to give you that sine of theta is 1/2, and I tell you theta is acute, all right, and then I also say let's find the value and we'll start with, let's just do the value of cosine. And we're going to use one of these little identities that we just wrote right here beside it. Okay. Well, we're asked to find the value of cosine. And we were given sine. All right, so if I look over here at these three identities, the first one uses sine and cosine. So that's the one that I'm going to use. All right, so sine squared plus cosine squared is 1. All right, so I'm going to substitute in place of sine, I'm going to put 1/2. So 1/2 squared plus cosine squared is 1. So now we just have an algebra problem. We get a fourth. Okay, and if we subtract that 1/4 from both sides, then I would end up with 3/4. Okay, now we take the square root of both sides. All right, so when I take the square root of both sides, I end up with the cosine of theta is plus or minus the square root of 3 over 2. I can't do the square root of 3, but I can do the square root of 4. Now, it told me in my directions that theta is acute. If theta is acute, then that means that the cosine of theta is positive. All right, if theta is acute, then that means that the cosine has to be positive. All right, so our cosine of theta is not plus or minus, it is just positive square root of 3 over 2. All right, now if you have a scientific calculator, which is going to be a requirement for this class, okay, now it doesn't have to be a graphing calculator, it can be just a scientific, but your scientific calculator must have sine, cosine, and tangent. That's what makes it scientific. So we're going to practice using those buttons. Okay, the first thing we need to check is make sure that your calculator is in the correct mode. There are two modes. Your calculator could be in degree mode or it could be in radian mode. All right? So you have to pay attention to that when you're working a problem. If I say I want you to find the sine of 61 degrees, obviously that is in degrees. So you need to make sure your calculator is set for degrees, and then we do the sine of 61, and we get 0 point. We're going to go 4 decimal places, so that's what you should get. You need to practice with the calculator. When you take your final exam for me, it will be where I can see you. And so I will see you working with a calculator. And you also, for tests and for lots of things that we do, you're going to have to turn in your work for me and show your work. Obviously here you're working on a calculator. So when you're taking your final exam, I will see your calculator. So just make sure you are practicing with the calculator you plan on using throughout the course. All right, the next one I want us to do is, let's do the tangent of 4 pi over 15. Okay, now that's a little different because that is not degrees. So now you have to make sure your calculator is in radians. Okay, so we're going to hit the tangent of 4 pi over 15. And this was not one I had written down on piece of paper, so let me go real quick. All right. All right, so I don't happen to have a scientific calculator in the room. Let me try this. Okay, the tangent, oh, there we go. The tangent of 4 pi divided by 15 is, we should all get 0.2094. All right? Now, what my math lab may ask you is they may say, you know what is the cotangent of 4 pi over 15? Now, a little different because if you will notice, your scientific calculator does not have a cotangent on it. It only has a tangent. So what we would have to do here is we know as tangent and cotangent are reciprocals. So we could do this. I know the cotangent is, I take this tangent value, I say 1 divided by it because they're reciprocals. So when you do that, you should get 0.9004. Now, please let me know if that is a struggle for you. You can email me. If we have a Teams meeting, that's something you might want to clarify. All right, so we are going to have to be able to work in radians and degrees on our calculators. Okay, so now let's use this in a problem where it would apply. In example number 5. So let's say I draw for you. My drawing went away. I don't know if you can see it. All right, so let's say I have a right triangle, and I'm going to put like a lake. All right, so there's my lake. Ooh, water, water. Lovely. I told you guys I'm not an artist. Okay. And let's say that this angle is 24 degrees. Okay. There's my theta. And we have 750 yards down here on this side. That is a 5. And then I want you to find for me, how far is it across the lake? So I'm looking for A. Okay, how far is it across the lake? So in this case, I'm looking for A. All right, well, now you have some decisions to make. We've got to decide which trig function will help me solve this. So my angle is 24. Notice that A is labeled across from it, so that is the opposite. So A is opposite. 750 is labeled touching it right there. So that is the adjacent. So I've got opposite and adjacent. So this is the tangent of 24 because opposite and adjacent are what I have in my diagram. So tangent is opposite over adjacent. So you would need to first set up your problem, all right? Now we're going to do algebra before we touch the calculator, right? To solve both sides, to solve this for A, I'm going to multiply both sides by 750. Okay, that gets the A alone for me, and so I have 750 times the tangent of 24 degrees is A. Now we actually can touch our calculator, making sure that our calculator is in degrees because that does say 24 degrees. So 750 times tangent of 24, you would get 333.92. And let's say I ask you to round that to the nearest whole number. Well, that would be 334. And these are yards. So A is about 334 yards. So you are going to have to decide which trig function do we use based on what's given in the diagram. Let's do another one of those. Not going to draw a lake for you this time. My drawing skills are not very good. Okay, so we've got our little triangle here. So what I want you to find this time is little b. All right, so now you have to decide which trig function are we going to use. All right, so the angle that is labeled right here is 53, that's our theta. So this little side b over here would be considered the adjacent side. 186 is our hypotenuse. Since I have those two things labeled, adjacent and hypotenuse, then we are going to use cosine of 53 is adjacent over hypotenuse. So we would multiply both sides by 186 because we got to get b alone. Now on your calculator, making sure your calculator is in degrees, you multiply and you should get, we're going to round to the nearest whole number again. We should get about 112, and these were in inches. That little squiggly right there means about or approximately. So b is about 112 inches. All right. So one other thing on your calculator that you need to be able to do. So make sure you have your calculator now. Some problems you will use your calculator, some you will not be asked to use it. Okay, so again, let's say we are going to find theta, and this time we are definitely going to have to use our calculator because I'm going to give you that the sine of theta is 0.6902. All right. So you don't type in the sine of 0.6902. That's not how you do it. So this time we're looking for the angle. So what we're going to do is we are going to say the inverse sine, that's that little -1, of the decimal that is given. That will give us theta. All right. If I take the inverse sine of the decimal, it will give me theta. So there is a button on your calculator that says sine -1. You need to find it. Make sure you know how to use it. Your calculator should be in degrees. And if you do this successfully, we're going to round to the nearest degree. We should get about 43 degrees for theta. All right. So that is it for section 2. If you have any questions, make sure you email me, and when you do, It's always best to take a picture of your work because I'm likely going to ask to see it. Otherwise, I will talk to you in the next video, or maybe I'll see you at the Teams meeting. Please try to attend the Teams meeting if possible. Otherwise, make sure you email me so that I know that you are not coming to the meeting, or we just have to have that interaction between me and you. So there we go. 5-3 will be coming up next.